This video is for pupils in first year studying physics, and it's designed to help you in plotting graphs. So, plotting graphs in physics is quite similar in many ways to plotting coordinates in maths. It's really very, very like it. So watch carefully and think about how that's done. Well, you'll usually be given some data to plot. I'm going to choose a mass and a weight example. So for example, you might be given some mass data and the corresponding weight of that mass. So we'll put the mass in kilograms and the weight, of course, will be in newtons. So let me just draw a line to make this reasonably neat. Let's get my ruler back. There he is. Okay. Well, let's imagine then that I've gone to a particular planet, I won't say at the moment which one, and I've taken a selection of masses available to me, and I've taken a spring balance to weigh them on that planet. And here are the results of my experiment. So I had a 2 kilogram mass. I also had a 3. It turns out I didn't have a 4 with me, but I did have a 5. And I had an 8 and a 9. So I don't have all the masses available. I don't have 1 and 4 and 6 and 7, but I do have these ones. Okay. Now let's imagine that the results of the weight turn out to be as follows. So for the 2 kilogram, let's imagine that that turns out to be 3.2 newtons. For the 3, it's 4.8 newtons. For the 5, it's exactly 8 newtons. For the 8, it turns out to be 12.8 newtons. And then for the 9, it gives me 14.4 newtons. Okay. And my task then is to plot this. Well, the question will usually tell you which is to be the horizontal axis and which is to be the vertical, so that would be the x and the y in maths. Usually in physics, when we're plotting a mass weight graph, this is usually the x-axis, which is the horizontal one. That one goes along the way left to right, and this one is usually the y. So let's fix this. We don't normally write the x and the y in physics, but that just lets you know where they would be if they were in. Right, so the first thing you've got to do then is draw your axes, and you want the graph to be as big as possible. So if you're given an A4 page, you want to try and fill that page as much as you can. So I'm going to draw my axes now. There. So we'll do the y-axis first, I think. Now I'm going to have to plot from 0, you always include 0, right up to 14.4 newtons. So I better give myself 15 newtons. Now in my square paper here, I'm going to let 1 square be a newton, so I need 15 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. That's 15 squares. That will give me 15 newtons on the y-axis. the side. On square paper you use, you have to choose whether you're going to let 1 Newton be a 1 centimetre box or whether 5 newtons would be a 1 centimetre box. You just have to gain experience in doing that. Now on my x-axis, that's my mass axis, I've got to go up to 9 kilograms. So I'll probably just go to 10 kilograms. That'll be 10 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that would just take me to there. But I've actually got a lot of space left. So if I've got another 10 boxes, 1, 2, 3, 4, 5, 6, 7, 8, I could actually get 2 boxes to be a kilogram, and that makes my graph bigger. And the bigger the graph, the better. Okay? So we've got our axes. What do we do now? Well, we need to label them. So the first thing I'm going to write down here is that this axis is mass in kilograms. It's vital you label the axis and give its unit. Then put in your origin. That point 0, 0 in maths, you would call it, coordinate 0, 0, is the origin. That must always be stated. On the y-axis, I'm plotting weight. I'm just going to write it sideways. And that's in newtons. Okay, so I now have my axes both drawn. They're both labelled, mass on the x-axis in kilograms with its unit kilograms, and weight in newtons on the y-axis. You don't need to write in the letters x and y. I only put those in to help you, okay? So I'm going to rub those out now. It's not wrong if you do write them in addition to the weight and the mass, but you don't need them. So I now have to plot my points. Here's how I do it. So my first point has a mass of 2 kilograms and a weight of 3.2 newtons. So in order to do that, I'm going to have to get my scales written in. So I said I was going to have 2 boxes for each kilogram. So make a little mark after 2 boxes. There we are. That's 1 kilogram. That's 2. Every time I go along 2 boxes, I go up a kilogram. 2 more boxes takes me to 7, 8, 9, and 10. So there's my x-axis scale. I can't plot the points, you see, until I've actually got the scales drawn. I need to know how many boxes to go along and then how many to go up. So there's my x-axis scale, the mass scale in kilograms. Now the weight scale, always look at the maximum one. The maximum weight is 14.4, so I'm going to go to 15. So basically 1 square per newton, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's my y-axis scale in place. Right, now we're going to start plotting. So let me rub those out. Don't need those now. My first point is 2 kilograms, that's this one, and 3.2 newtons. So I go along to 2 kilograms, here I am, so there's my 2 kilograms, and I'm looking for 3.2 newtons. Well, there's 3. I don't have any grid lines in between 3 and 4, so I'm going to have to estimate where 3.2 is. Well, it's 1/5 of the way between 3 and 4. So if I go to 2 and I go up 3.2 is about there. Now, when I get to the point of doing the cross, I do a little cross like that. Okay. Now, you wouldn't normally draw in these dotted lines, so I'm going to get rid of those. That was just to show you where the first point would go. So look again at that first point. That first point is 2 kilograms and 3.2 newtons. 2 kilograms, 3.2 newtons, just a little bit above the 3. Okay. So there's my first point plotted. Always plot a little cross, a wee vertical line and a horizontal line, and it's where the two little arms of the cross cross over each other that the actual point is. My next point is 3 kilograms and 4.8 newtons. So I go to 3 kilograms, there it is, and I want to go up to 4.8. Well, there's 4. 4.8 is just short of 5, so it's about there. Okay, maybe actually slightly further up than that. You've got to estimate these things as best you can. There we are, 4.8 things round about there. Now notice that in my mass data on the table, there are quite a lot of numbers missing from the series, like I don't have 1 kilogram and I don't have 4 kilograms. That doesn't matter. Your scale should always include all the numbers between 0 and whatever your biggest one is, in this case 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You do not just copy 2 and then go along 2 boxes and put 3, then go along 2 boxes and put 5, right? Because then you've missed out the 4. So you always have all the numbers in the sequence on the axis, 1, 2, 3, 4, 5, even although they're not in the table. Okay. So my next point to plot is 5 kilograms and 8.0 newtons. So there's the 5 kilograms. So I go up, there's 8 in there. So 5 and 8, that's bang on a grid line, that's a nice easy one, like that. Okay. Right, so far so good. 8 kilograms and 12.8 newtons. So 8 kilograms is there. 12.8 newtons, so it's between 12 and 13, but it's closer to the 13. Somewhere there. And that's that one done. And then my last point, 9 kilograms and 14.4 newtons. So there's my 9 kilograms there. And I want to go right up to 14.4. Well, 14.4 is almost halfway between 14 and 15. That would be 14.5. So it's just slightly short of halfway. Maybe about there. Now remember, you'll never get this exact. You just have to do your best. Having plotted the points, don't just stop there. There's a final stage to go, and that is you need to draw the best fitting line. Now to do that, you do really need a ruler. And what you do is you take your ruler, ideally a transparent ruler, and you line it up with your points. Now you might find some of the points are slightly above and some are slightly below. That's perfectly okay. And you draw what's called the best fitting line. And I'm going to draw this one now. Something like that. That's my best fitting line. Okay. Now it's not uncommon to get some points which are not bang on the line. For example, you may have got some data where a point was a wee bit above the line like that, and then maybe one there was below, maybe one down here was above, and one up here, let's say, was below. Right, those red ones could very well be real points. Don't worry about that. Not all the points will lie bang on the line. That's because of experimental error. Okay, and that's how you plot a graph in physics. Okay. one final question then. So question. What is the weight of a 1 kilogram mass on this planet? Let me rub out these red crosses. That was just to show you where the crosses could have been. Well, to answer this, again, you should take your ruler and you want to know the weight of a 1 kilogram mass. So you go to the 1 kilogram part of your axis, there it is there, and then you draw a dotted line. This should be done with a pencil. Up to where it meets the line. And then draw another dotted line, horizontally this time, across to the y-axis. And you've basically got to estimate what that weight is in newtons. Okay. Now, it's quite tricky to do this, but it's clearly in between 1 and 2. It looks quite close to 1.5 actually, but I think I can tell by looking that it's a little bit more than 1.5. Now I don't know whether it's 1.6 or 1.7. I'm going to guess that it's 1.6. Okay, 1.6. So I reckon then the answer is 1.6 newtons from the graph. Now it's very important that you draw the dotted lines on the graph to let the marker see how you got your answer, and always write your answer in the appropriate place. And then the final question then, which planet were these measurements made on? Well, how are you going to work that out? Well, you've just worked out that a 1 kilogram mass weighs 1.6 newtons. So you know how many newtons there are pulling down on 1 kilogram. You know the number of newtons per kilogram. In other words, you've just worked out the gravitational field strength. So on this planet, the gravitational field strength G is 1.6 newtons for each kilogram. So it is, well, if we go back to our table, and you'll always be given a table of gravitational field strengths. I haven't got it here, but you will have seen them. And when you look up your table, you'll find that we're on the moon. And that's from the given table. I don't have the table in front of me here, but you would be able to look it up. So that's how you do graph plotting in first year physics. It's worth practicing this as often as you can, and you'll definitely get better at it the more you try. So you might want to try plotting this particular graph. If you don't have any graph paper, you could use squared paper from your maths jotter, or you can download and print graph paper from graphpaper.com. And that brings us to the end